This is 7.5, Lesson 3, which is titled Solving Quadratic Equations by Factoring. What we learned in the premise of this section was that if two terms or two expressions multiply to be 0, then either the first term equals 0 or the second term equals 0. Or in other words, if we get to a more complicated problem based on the premise, if we had x minus 8 times x plus 2 equals 0, then either x minus 8 equals 0 or x plus 2 equals 0, because one of the factors has to equal 0, because anything times 0 is 0 if we're solving an equation that's equal to 0. So the focus of lesson 1 was this method here, was how to solve by factoring when you have ax squared plus bx plus c is equal to 0. And then last lesson was based on two types of factoring. One was a difference of squares when the middle term, the x term, was missing or equivalent to 0. And you can look at the lesson for that. And the second one was when you have a greatest common factor. The last method in this lesson is we are going to be looking at how to factor in more than one step. So the first thing that we have to do before we can start factoring is make one side equal to 0. Because you can't solve a quadratic equation if one side doesn't equal 0. So in this case, we would have 2x squared minus 2x minus 4 equals 0. Now the first thing you want to look for in this case is a greatest common factor. All three of these terms can be divided by 2. So I'm going to treat my greatest common factor as being the number 2. So if I factor a 2 out of every single one of those terms, so if I divide the first term by 2, I'm going to be left with x squared. If I divide the second term by 2, negative 2x divided by 2 is just negative x. And if I divide the third term by 2, or factor 2 out of it, negative 4 divided by 2 is negative 2. The next thing you want to do, so that's the first step of factoring, is that this trinomial here can still be factored. So you can factor x squared minus x minus 2. And that could be done using the area or box method. So the two values that multiply to be x squared are x times x. And the two numbers that multiply to negative 2 and add, when you combine the terms, to negative 1 would be negative 2 and positive 1. And let me show you why. Because this term would be 1x, because 1 times x is 1x, and this term would be negative 2 times x, which is negative 2x, and those do combine to be negative x. So your factors here would be what I have in blue, what I have in green, and what I have in red. So our factors would be, let me just create some room here, 2 times x minus 2 times x plus 1 equals 0. Now, the solutions would be when one of these factors equals 0. Now, the first thing is, can 2 equal 0? No, it can't. So that's not going to be part of your solution. So either x minus 2 equals 0, which would give you a solution of positive 2, or x plus 1 equals 0, which when we solve for x would be x is equal to negative 1. Okay, and again, I could graph the original function. So if you look at this original function here, 2x squared, once I've made one side equal 0, 2x squared minus 2x minus 4. Let me go ahead and graph that for you. So y equals 2x squared minus 2x minus 4, and I graph that. You will notice that the x-intercepts, because those are also called the zeros, or the solutions, are negative 1, as I have here in red, and positive 2, which is what I have here in green. And here's the last problem. We're going to want to make one side equal 0. I think the easier thing to do is to make the left side equal 0. The reason is we will have all positive terms in that case. Because if I add 1/2 x squared, or 0.5x squared, the left side equals 0, and the right side would be 0.5x squared plus 5.5x plus 14. Okay, and in this case, it's a little bit more difficult. Since you probably don't like integers, I would treat your greatest common factor for this entire expression, treat it as being 0.5. Okay? So if I divide 0.5 out of all of those terms, I can even show you on my calculator. 0.5 divided by 0.5 is 1. So this term would just be x squared. 5.5 divided by 0.5 is 11. So this term here would be 11x. And the last one, 14 divided by the greatest common factor of a half. 14 divided by 0.5 is 28. So this term here would be plus 28. And now what you'd want to do is factor x squared plus 11x plus 28, which we have done before. So x squared, 28, and 11x. X times x is x squared. And 4 and 7 are the constant terms, and I'll show you why. This would be 7x, and this term here would be 4x, and those add to be 11x. So your factors for this problem are what I'm circling in blue, 0.5, what I'm circling in green, x plus 4, and what I'm circling in red, x plus 7. So the factored form would be 0.5 times x plus 4 times x plus 7 equals 0. Now the coefficient 1/2 can never equal 0. So it can't equal 0, so it's not part of your solution. But x plus 4 can equal 0. It would equal 0 when, if I solve for x, when x equals -4. That's a solution. And x plus 7 equals 0 if I solve for x when x equals -7. So our solutions appear to be -4 and -7. And let me, just before we finish this lesson, let me go ahead and graph this function here, 0.5x squared plus 5.5x plus 14. So if I go ahead and do that, 0.5x squared plus 5.5x plus 14, and I graph that function, what you'll notice is my zeros, or my x-intercepts, or my solutions are at -4, like I have here in green, and -7, like I have here in red. If you're in my class, what you will do now is get a handout from me on 7.5 Part 1, and then move on to that.